Hi, I'm Patrick.
And I'm Tim.
And this is a demonstration and explanation video for a project we called Sawlver, which was a puzzle-solving app for iPhones and iPads.
And this is the final project for our computer vision class.
So the context for our app is that you can imagine yourself trying to solve a puzzle. You have all the pieces spread around on a table and you don't know how to solve it. Essentially what you do is, with the app open on your phone or iPad, you take a picture of all the pieces scrambled, and then you take a picture of the box or the solution image, and the app effectively tells you how to solve and move all the pieces together to solve the puzzle. So we have the simulation running here of that exact process. So here we have the page where we actually take the two pictures. I have a sort of debug or built-in key to give in some default image sets just so we can quickly work with that. But again, this top one is like the image of the box itself, so to speak, and the bottom is all the individual pieces. They don't necessarily have to be square, they can be rotated and so forth, but this is just an example. So then we press next, and in the back end it does the segmentation. It recognizes how many pieces there are, in this case 4, and then it does all the heavy lifting and the processing to try and solve the image for you. So as Tim will explain later, we are using OpenCV, which is an open computer vision language, to do all the processing. It's a multi-platform tool which is very useful and very easy to work with on mobile devices such as this. Very shortly we will see an output of the processing to basically it's showing where it thinks all the pieces are. So for example here, this piece up here, it thinks is in this corner here, which is correct. And you can scroll through all the different locations to see where the puzzle thinks that those pieces should be. And as the final step, we're able to see how it's actually solved or arranged back together. So this short animation shows basically how the original image, the original positions of all the pieces should be moved so that they're in the right location. You can, for example, restart that animation. So if we go back to the home, we can use, for example, another set of images. I'll use another one that's a larger set, but you can see we have some different complex images uses. They all, generally speaking, work. Here we're going to use a 3x3 puzzle with some rotations involved. So I press next. You can see again it now has segmented all the pieces. It recognizes that there are in fact 9. And then again it will process for a little while. So here we can see that for this larger picture it has again identified all the pieces and tried to place them around. If we go straight to the animation, you can see how it tries to arrange it together. So we didn't actually implement the rotation aspect of it, so it doesn't procedurally rotate it forward. But we do have estimate or ideas of the rotation of each individual piece. If you go back to the previous page, you can see that each puzzle piece that has an associated degree of rotation attached to that, so that could be a potential improvement. That's effectively the front-end user interface of our app.
The entire project was made in Objective-C for the iOS front-end user interface, and with C++ for OpenCV integration. At the beginning, we have to first segment out the puzzle pieces from the background through a series of segmentation techniques. These include adaptive thresholding, HSV space thresholding, etc., and other techniques like active contours, dilation, erosion to filter out and to segment out the puzzle pieces from the background. After we've gotten all the key points, we went through 5 different strategies for removing irrelevant key points. These include removing based on their proximities with respect to each other, their relative orientation, how close they are with to the borders of the puzzle piece, and etc. And at the end, we have approximate locations of all the puzzle pieces with respect to the original puzzle image solution to make further predictions.